A rancher at Shady Acres can afford up to 300 feet of fencing to build a rectangular pen that must enclose an area of at least 2,600 square feet. For our purposes, we're going to let the X excuse me, be the larger of the two dimensions unless they are equal. So determine which of the dimensions listed below satisfy the restrictions on the enclosure's necessary perimeter and area. Well, how do we find perimeter? Add all the sides? So how many X's are there in a perimeter? Two. There's this one here and this one here, right? And then how many widths are there? Two, this one here and this one here. So 81 plus 81 plus 58 plus 58. Who's going to start today? Who's going to start? We're going to go around the room to make sure everyone gets to participate. So Abby, would you start? 81 plus 81 plus 58 plus 58. $278. Excellent job. Okay, 278. What about 111 plus 111 plus 21 plus 21? Do you mind sharing your calculator with your table mate so she can do hers?
I got it.
It'll be your turn. It'll be your turn in a minute. Thank you for volunteering, but it'll be your turn in a minute. $264. Excellent. Okay, Clea? 92 and 59. 302. Very good. 71 and 39. Jake, you got that one? Excellent. 220. Will?
Let's see. 120.
Uh-huh.
Plus 281.
281. So that takes care of the perimeter column, right? So what about the area column? Excuse me. How do we find an area of a rectangular pen? Okay, so what do we have for the first one? Would you do that?
It's 4,698. It was
4,
my turn.
6, 9, 8. Okay, now you can take your turn since he stole your turn. What about 111 and 21?
2,330.
Okay. Sierra, what about the next one? 92 and 59. Yes, ma'am, because we're finding an area. Yep.
5,428.
So why did you question that? Because I know you did it, and then you questioned it. Was it because it was so different than the others?
Yeah.
That's okay. That's all right. All right, what about the next one?
2,769.
2,769 is another area, right? Abby, you have the last area for me? 2,460. Okay. Kirsten, I've got another column here that says, will it work? So, based on what I said in the very first sentence up here at the top, I need to know if this width and this length will work. What has to be true about the perimeter?
It has to be up to 300.
Correct. And what has to be true about the area?
It has to be at least 2,600.
Okay, so will this first one work?
No.
So it has to be up to 300. So use some math words for me. What does it have to be about 300?
Yeah.
If it's up to 300? Is that less than 300 or greater than 300?
Gregor.
Less.
It's less than 300. It's up to 300, so it's going to be less than 300. Is this one less than 300? Yes. And what has to be true about the area?
It has to be
So use a math word for me.
Less than, no,
Greater than, right? It has to be at least 2,600. So tell me now, will this work?
yes, it will.
Yes. Okay. Kalia, the second one, the 111 by 21, will this work?
No,
Why not?
because the area is greater.
The area is the one that's causing it to be a no. Does that make sense?
Yes.
Jake, will it work?
Yeah.
Jake says yes. Do you agree with him? Why not?
Because the perimeter is greater than 300.
Remember, it has to be up to 300, so it has to be less than 300. Does that make sense? Okay, so this is what's causing it to be a no. Aiden? 71 and 39, does that work?
No. Wait.
Has to be at least 300 and, sorry, up to 300 and at least 2,600.
So yeah.
So yes, because this is less than 300 and this is greater than 2,600, right?
Yeah.
And then, well, what about the last one?
No,
No, why?
because it's not up to 2,600.
So it's the area that's causing that answer to be no, correct?
Right.
Okay.
Alright.
Ethan,
Yes.
how do we find perimeter again?
Add up all the sides.
You think you can answer by yourself next time instead of your table group telling you the
Yeah.
answer? You didn't. They didn't even give you a chance to think, did they? Rude.
Don't say they.
Oh, okay, sorry. He didn't give you a chance to think, did he? Okay. So if we're finding perimeter, how would I write that as an equation?
What?
How would I write perimeter as an equation? If I'm adding up all the sides, x plus y
Sorry.
plus x plus y, right? How many x's are there?
2.
And how many y's are there? So couldn't I write 2x plus 2y? I don't know why I wrote 0. And what does that have to relate to? What's wrong?
It's 2y plus 2y. I thought it was 2x plus 2y. Oh.
Thank you. I think I said that and wrote y. Sorry about that. Thank you. Thank you for correcting me. 2x plus 2y. What does that have to do with 300? A second ago I said what's the equation for perimeter, but is this actually an equation that I'm trying to write? Even if you questioned it before, look at the title of the column. It's an inequality, right? It doesn't say he's going to buy 300 feet of fencing, does it? It says he can afford up to 300 feet of fencing. And we said just a minute ago, how does that relate to 300?
Oh, it's less than.
It's less than or equal to 300, right? Now, if I subtracted 2x from both sides, and then if I divided everything by 2, that will give me my graphing, the form that I'm graphing from. So y is going to be less than or equal to 150 minus x. Please stop talking. Does everybody see where this came from? I subtracted 2x from both sides to get 300 minus 2x. And then I divided everything by 2. That gave me the y. That gave me 150. And that gave me minus x. Everybody okay so far? All right, whose turn is it?
Aiden's, I think. Or Wheels.
You already went. Okay, Sierra, you ready? How did we find area again? Of a rectangular multiply? Okay, so what does that look like?
2x.
X times y. Yeah. X times y. Okay. And how did we say that has to relate to 2,600? It has to be at least 2600. So how does that relate to 2600? Greater than or equal to. Now, I need a form that I'm graphing from, so I'm going to divide both sides by x, and I get y is greater than or equal to 2600 over x. Okay? Now, there's one more restriction, and we actually talked about it up here, but it's not in the first paragraph. Okay? It says let the length x be the larger of the two dimensions unless they are equal. Let the length be the larger of the two dimensions, or they could be equal. So how does x and y relate this time? X is what? Larger, or they're equal. So if I flip that around so that the y comes first, do you see that it is less than or equal to x? Any questions? Use a calculator to help you sketch the graph of this system of inequalities. Okay. So I've got my calculator. Do you have yours? So I need a graph. So I need to put in 150 minus x. Uh-oh. It must be broken. That's what you guys always say when this happens.
No, you gotta change the camera angle.
I have to change the window, or camera angle, okay. But I have to change the window because it only goes up to 6 and only over to 10. And my y-intercept on this graph is 150, right? So menu. The other thing I could do is look at the graph that they gave me and change my window to match the graph that they gave me. Are you okay with that?
Yeah.
All right, so I'm going to change my window settings. So where does it start? On the x-axis, how far to the left does it go? To 0, right? I'm going to go ahead and put -1 just so I can see the axis. And I'm going to hit tab, and how far to the right does it go? 150. And then I'm just going to leave it auto because it will decide how to count. Or I could put it at 10 because that's how it does here, right? Now, how far down does it go on the y-axis? 0, so what am I going to put? -1 so I can see the axis. And how far up does it go? 150. And how does it count? By tens. Now we can see it, right? And I can copy that, but I already I know I could have graphed that one without seeing the graph, because I know the y-intercept is 150 and I know the slope is -1, so I could put a dot on 150 and go down 1, right 1, all the way across the page so that you can see the line that is there. Now, is this line a dotted line or a solid line?
Solid.
Because it's less than or equal to. Yep, that's correct. Now, should I shade above or below this line? Because I should shade below because it's less than. Now remember, I'm not going to shade right away. I'm going to tell myself where to shade. So then when it's time to shade in a minute, I'll know exactly where to shade. Okay? Now, how do I go about graphing the next line? I'll probably need the calculator for that one, right? So 2600 over x. Do I just put a swoosh on there? What do you think I should do? I could go to the table, couldn't I? To the y2, and I could look at some values here. Now I can't do anything until it's less than 150 on my graph. Now look at that, 20 is right at 130. So 20 and 130. I'm going to go and graph this one in red. Go find some nice numbers. Oh, look at that. 26 is 100, so 26-ish is 100, so like right there. Now, I could go to my table and edit my table settings. And instead of making it start at 25, I'm going to make it start at 0, but I'm going to make it count by tens. Wouldn't that make a little bit more sense to count by tens, because that's how my graph is counting? Do we have to do that? No, I don't. I don't have to do that at all. But look how much easier it is to find points on my graph, right? So if x is 40, y is 65, 50 and 52, which means 50, well, we don't have to worry about that right now. 70 and 32.5, so ish right there. Why am I only looking at the second column and not the first column, the first y column? That was the first equation, right? This is the equation I'm looking at, the 2600 over x. So when x is 100, y is 26. 130 is 20. So that gives me a pretty good picture of my graph, doesn't it? Uh-oh. That's better. Do you mess up sometimes when you draw your graph? Yes? We're just trying to, this is not a nice neat line where I could slap a ruler on the paper and trace it, right? We're just trying to go where the dots take us. So is it okay if we mess up like this? Yes? You guys probably have it a little bit easier because you could erase that line, right? I can't because I'm drawing with markers so you could see it. Are you okay with that? So this one I did in red. This one I did in black. The first one. Let's see what's going to be easy to see. Maybe this color. No. This color. Let's do this one. How do I graph the line y equals x? That just starts at 0 and rise 1, run 1, right? Oh, we have to look at the, sorry, we need to go back and look at the red one again. It's greater than, so is that inside this curve or is it outside the curve? Inside is greater than. Okay. Now y equals x, we're going here. Our intercept was 0, then we rise 1, run 1, or in this case rise 10, run 10. That's still equal to 1 though, right? Okay. And am I shading above or below this line? Because it is less than, right? So I'm shading below. So where is the final area that I'm shading? So this area. So what do points in this area mean? They're possible dimensions for my rectangle, right? So give me somebody, let's see, whose turn is it? Where are we for turns? Are we at Felicia? Felicia, can you tell me one point that would be a solution to this system? 130. How do you guys feel about the point 130? Is that a possible solution? And how do you know it is? It's in the shaded area. That means if this rancher is building his rectangle, his fence, this length is 100 and this length is 30. Okay? Abby, can you tell me another possible solution? 90, 50. Do you guys agree with Abby? 90, 50? So Abby, tell me about the rectangle again. The x would be 90. Y would be 50. Perfect. Kirsten. 70, 40. How do you guys feel about 70, 40? That's in the shaded area, so it's a solution, right? All right. How do you feel about this solution? Nobody said anything like that. 84.6, 49.1. It's like right there. Isn't that in the shaded area? How come nobody thought of something like that?
Because everyone just thinks.
Because it's weird, right? Everyone thinks of the whole numbers. You guys might have even thought of 84 and 49, but you don't want to deal with decimals if you don't have to, right? But I need you to know that it's possible. Okay? Now I have one more thing that I want you to think about. Okay? And that one more thing I want you to think about is 130, 20. That's right here. Is that a possible solution? Why is that a possible solution?
Because it's a solid line.
Because it's a solid line, because it is or equal to, right? All of these are or equal to, greater than or less than, whichever one, but they are all or equal to. So not only is everything inside the shaded area a possible solution, but for this system of inequalities, everything on the lines are also possible solutions, right? Does that make sense? Okay. The other worksheet that I gave you is called macaroni and cheese. Same kind of thing. There's a table at the top for you to fill out. There's inequalities, except the inequalities, what do you notice about the inequalities on mac and cheese?
Mac and cheese is
Didn't they give you the inequalities to use? Yes, they gave them to you. You didn't have to figure them out. And then there you have to graph and find points of intersection. I think in the directions it says list other several possible pairs of dimensions. How many do I want? 5. Nice. Anybody have any questions?